Good afternoon.
Good afternoon, teacher.
Sorry, my laptop had to re-upgrade itself, so ended up delaying. Last time we had discussed motion, and we had described velocity time graphs. So today we have to introduce what we call vertical motion under gravity. It may be similar to what we discussed in the morning, though here we don't do many examples like in math. And also here we need a lot of the definitions stated rightly. And then we have some explanations which come as a result of the graphs of speed and velocity for bodies that are thrown vertically upwards. I don't know why others are not coming in, but with that, let's have introduction to vertical motion under gravity. So in vertical motion under gravity, we have what we call acceleration. Acceleration due to gravity. And this acceleration due to gravity is normally known as small g, whose definition is the rate of change of velocity of a freely falling body and a constant force field and a constant force field like the gravitational force field, force field. So that velocity changing with time as a result of a free falling body falling under a constant force field is what we are terming out to be acceleration due to gravity. So therefore, I was saying, someone just take me out. Acceleration due to gravity is the rate of change of velocity for a freely falling body. This is vertical motion that we are discussing. Then the write-up, you will find it in the notes. And we had said acceleration is actually g, which g is 9.81 meters per second squared. Now, since we are in physics, the acceleration is 9.81 in physics. This is for physics. Then for those of us who offer math, acceleration g is 9.8 meters per second squared. And from equations of motion, we know that v is equal to u plus at. We also know S is equal to UT plus a half AT squared, and we know V squared is U squared plus 2AS. So if a body is considered to be moving upwards, when a body moves upwards, we shall consider the body to be in this form, with this as its weight, and then we overcome. We shall be having a force which is not there, that is pulling the body upwards. When you throw a piece, as it goes upwards, there is no force pulling it. But you know there is always the weight of a body that always acts vertically downwards towards the center of the earth. We shall see more of that when we come to gravitational physics and space science. This will become 0 minus mg to give us the resultant force, whereby the resultant force is always the product of force coming from the acceleration times the mass of the body. So this is what we call the resultant force. Therefore, a negative mg is equal to ma. When you divide by 2, acceleration is always a negative g meters per second squared. So this is the acceleration of a body moving upwards. Acceleration, the body moving upwards. Now, unlike in math, they cannot ask you to show, but in physics, they can ask you to show that the acceleration of a body moving upwards is given by a negative g meters per second squared. So you should be able to arrive at that. Whereas when a body is coming back down, that is when a body is falling downwards, still it will be moving in this state, whereby this is the direction of acceleration. This is 0, this is mg. So the mg overcomes the no force to give us the resultant force. And with this, mg is equal to ma. Therefore, the acceleration is a positive g meters per second squared. So it is positive when the body is falling back to the surface. The body is falling back to the ground. Furthermore, having realized vertical falls and risings, we can then now state the equations of motion for a body that is moving under gravity. So for vertical motion, the equations are as follows. V is equal to U plus AT. It will become V is equal to U minus GT. When going up, then V is equal to U plus GT when falling down. This is going upwards. This is going where? Downwards. S is equal to UT plus a half AT squared. This will give us S is equal to UT minus a half GT squared, which is the same as S is equal to UT plus a half GT squared when it's coming down. Then V squared is equal to U squared plus 2AS. With this, V squared is equal to U squared minus 2GH for the height, and V squared is equal to U squared plus 2GH when it's coming down. So those are the basic definitions that arise when we have motion of the body which is vertical. Now, other definitions come up, like time to reach maximum height. Time to reach maximum height. Whereby at maximum heights, V is 0. Why is V 0? V is 0 because when the particle leaves the surface and goes on rising, it goes overcoming a lot of resistance with air. In math, I will not give such details, but in physics now we speak the real science of what is really happening. So as the particle goes up, it is encountering a lot of air resistance. There are molecules of the dust in the atmosphere. There are so many molecules it is overcoming. So it goes on retarding. So if it is retarding, time comes when it cannot overcome those forces, those molecules anymore. And at that instant, it is going to experience 0 velocity, and that is when it has reached its maximum height. Then it starts to fall back. When falling back, the speed or the velocity goes on increasing. Why? It is because the gravitational pull of the planet, for example, the Earth, is pulling these molecules downwards, is pulling the weight of the body downwards. So because these molecules are also going in the same direction and the mass is also going in the same direction, they are all having the same resultant direction of motion. So there is less resistance to motion. That is why when coming back down, its velocity goes on increasing. So it appears as if it is going very fast when coming back to the ground. So with that note, from V is equal to U minus GT, this is going to be equal to 0. U minus GT would be 0, and thus the time it takes to reach maximum height is U over G. Then the second time is what we call time of flight, whereby for time of flight is this one. If a particle has been projected from the ground and goes up and comes back, then the displacement it has covered is 0. So from S is equal to UT minus RF GT squared. This is going to be equal to 0, which will give me T into U minus GT over 2 is equal to 0. So it's either T is 0 or U minus GT over 2 is 0. And T is 0 when the particle is still here. But when the particle has reached here, there is another T which we are looking for. That is what makes the time of flight. The time it takes the particle to leave the point of projection to come back to the same level of projection. So U minus GT over 2 is actually 0. Therefore, T is equal to 2U out of G. And with this note, we normally call this T capital T, time of flight. And always time of flight is twice time to reach maximum height. So if you look at it carefully, the time of flight is twice the time to reach maximum height. Or the time of maximum height is a half time of flight, right? The other definition we can get out of this velocity with which hits the ground. Now, if I assume the particle reached maximum height and then came back, we have realized that when you are here, the initial velocity here is 0 because the particle stops Then when you're reaching down here, what is the velocity you're coming with? So from V is equal to U plus GT, because it's coming back down, G is positive. Then final velocity would be 0, this is U prime, plus GT. But do you realize that in actual sense, if it's coming back to the same level, the time it takes, because of GT, when you come here, this also shows you that U is equal to GT. So if this is equal to GT, it means V is equal to GT, which GT is also the same as U. So when a particle goes and comes back to the same level as it left, it will come back with the same velocity as it left. So the velocity of leaving a given level is the same as the velocity of coming back to that same level. Now, what if it is bypassing that level? Or it has not reached that level, it has stopped somewhere, and they're asking you with what velocity has it reached that somewhere? Then this is what is going to happen. You will see that if the particle left with this position, then it comes back to this point, perhaps with a final velocity we don't know, left here with U. And then this final velocity we don't know, it is going to cover it in a height, small h. Yet up here, the velocity is 0. So from V is equal to U plus GT when coming down. We can also conclude that V squared is equal to U squared plus 2GH. Because it is starting from 0 up there, V squared is 0 plus 2GH. Therefore, V is going to be the square root of 2GH. So this is the final velocity. With which a body covers any height. Or the body hits the ground. Another definition is when the body goes below the level of projection. The particle has been here and it has been projected vertically upwards. Then it went and came down like this to come and meet the ground. And where it is projected from maybe has a height, capital H. And the particle is being projected at the speed U. Yeah. It will first come and meet this level of projection. Remember, I said that level, vertical displacement is 0. If vertical displacement is 0 there, it means it is only covering a height below the point of projection. So height is always negative. So if height is negative, we shall have the following. 1. From S is equal to UT minus GT squared over 2. Because we are looking at a point when it is going from the beginning. So you take it as if it's a body going upwards. That's why I'm using G is negative. Then I'll have a negative H is equal to UT minus GT squared over 2. This is the relationship we shall use when a particle has gone below the level of projection. So final question on these definitions, if I proceed. Any question here?
Teacher, I was requesting you again explain this last one when the body goes below the level of projection. I'm kind of lost.
Okay. Can you see my picture? You see my
Yes,
picture,
teacher.
right? You
Yes,
see my
teacher.
board here? The particle is resting at the edge of the board. Then I throw it up, it goes and then comes and bypasses the board. When the particle goes up, it covers a vertical height, which is positive. On coming back, it changes direction, it covers a negative height. When you add the two heights, negative and positive, you get zero. That's why I'm saying when it comes back to this same level where it left, the displacement is zero. Now, the only height it is left to cover is the height starting from the level up to below where it's going to land. So that height it is covering it in a negative direction. Remember, as it went with a positive h. On coming back, it came back with a negative h. But so far, the distance here had become zero, but it was in the negative direction. So the distance remains negative. That is why we are taking the h negative. And the reason why we are using g negative, it is because motion is considered from the beginning up to where it is ending. And from the beginning, the particle was projected upwards. Okay.
Okay, teacher.
Then another definition also to talk about in detail is time above a given height. Time the particle spends above a given height. In that sense, we can look at an illustration like this one. If a particle is around here and it has taken time t1 to reach this height, h1, h, then it comes back to the same level after a time t2 from the point level of projection. Then the time it takes would be t prime, which would be t2 minus t1. So in solving for this time, you'll substitute in the h is equal to ut minus gt squared over 2. Then you solve the quadratic equation. Until you attain t1 and t2, then you subtract. So that would be the difference in the time of travel above a given height. So those are our definitions for the vertical motion. So we are going to look at the examples. So the first example is going to be so you can take a screenshot, you'll merge with the notes. Okay, example 1. particle is projected vertically upwards with a speed u is equal to 10 meters per second. Find how long it takes to reach a height of 10 meters from the level of projection. Two, find the time, take screenshots, spends above 10 meters. And the time it spends above 10 meters. So according to this question, here we are projecting a particle to move upwards. It's going to reach 10 meters. So they are saying, find how long it has taken to reach there. So they're asking you to find T1. From S is equal to UT minus GT squared over 2. It is 10 is going to be equal to 15T minus 9.81 T squared over 2. So give me 4.905 T squared minus 15T plus 10 is equal to 0. Can you put in a calc and give me the answer? Press the calc. What answer do you have?
$2.0761.
T1 is 2.0761. T2
0.9820.
0.20.
9820.
Now physics, you can write 2 decimal places. They are fine. So therefore, it means T1 is 0.98. T2 is 2.08 seconds. So the time it takes to reach that height is this one. But the time it takes spends above, when they go to the above bit, we have to be in position to go by this. To find T prime, which is going to be T1, T2 minus T1, which is equal to 2.08 minus 1 point, minus 0.98. What answer do you get?
1.1.
1.1. 1.1 seconds. So the first answer, the question, you should have selected which because the question is, which answer do I know that it's the first answer it takes to reach that height? The shortest time is the time it takes to reach the height. Then the second time is the time it takes to reach the height again on coming back from the point of projection. Then the time it takes over that height is the difference between those two. So you can have that down.
Teacher, in physics, are you supposed to show the bulldozer method when you're working?
No, in physics, you can give us the answers. It is in mathematics where we require you to show us the bulldozer method, the method you're using to solve. But in physics, it's okay, you can press the curve. Okay, let's have another one. So if I look at another example, is there a person who does not offer math? The other person is Amina, but I think she's not here today. I don't know why she ever misses. There is a question I've forgotten. They can ask you to sketch a graph of velocity against time for a body thrown vertically upwards and then falls back. You know, velocity is a vector. It has both magnitude and direction, whereby they give you 3 marks on this question. You have to explain. So for velocity, if the particle is thrown to be given an initial velocity, then it will come to maximum height. Then it will return. On returning, the velocity will change direction. So this is point A, point B, point C. Since I told you that when a body leaves a position and comes back to that position, it will come back with the same speed as it left. So at C, the body is having a velocity which is negative u. Now, when they ask you for such a question and they put there 3 marks, you have to explain the parts A, B, and C. So when the particle is projected upwards, what happens? The velocity goes on reducing. When a body is projected, so the solution is when a body is projected, the velocity goes on reducing or retarding until it becomes 0 when it reaches maximum height. It reaches maximum height at B. The body then reverses direction and starts increasing the velocity again. But in a negative direction. Until it comes back to its level of projection. With the same speed as it left. Okay, so that is the explanation for that graph. The particle is projected upwards with a speed u, goes on reducing until it reaches maximum height, where the velocity becomes 0. And then at maximum height, the body will reverse direction. When it reverses direction, it starts increasing its velocity again, but in the negative sense, until it will attain the velocity with which it left at the point of projection. Then another graph, speed against time. Do you have a question on that graph? Now, speed is not a vector, it's a scalar. Speed has only one direction. Speed is magnitude, it's just size. Its direction does not matter. So speed has only one direction, which is the positive. So the velocity will fall, the speed will fall from u until it reaches maximum height. When it reaches maximum height, the speed becomes 0. Then when the body reverses, the speed starts increasing again. But you shall not have to consider the negativity in this sense. Why? Because all through speed is going to be positive. So that is why we have the shape of the graph as a V4. This is point A, point B, point C. So at A, the particle is projected with a speed u. Particle is projected with a speed u, and it goes on reducing until it reaches maximum height. It then falls back as the speed goes on increasing. But since speed is a scalar, since speed is a scalar, the direction of the graph is not reflected in the negative. So those are very two sensitive definitions on those two graphs, which requires everyone to be in position to have it. Any questions there? Someone has sent me the numbers. Okay, let's have another number. Take the screenshot. If there is no mathematics, if all of you are mathematicians, then the solving for mathematics is enough. If some of you are physicists only, don't solve Humphrey, don't solve Bostock, you stop at understanding mechanics and Roger Moncaster. Example 2. A stone is thrown vertically upwards with a speed of 14 meters per second from the top of a tower. Mm-hmm. 20 meters high. Question 1, find the time it takes to reach maximum height. Two, find the time it takes to come back to the same level of projection. Then 3, find the time it takes to hit the ground. This is our tower. Project a stone from here. I think everyone has ever thrown a stone. But nowadays, kids don't throw stones. Yeah? You may remember in our time, everyone has ever thrown a stone. So U is 14. This is the level of projection. This is maximum height, where V is 0. Here S is 0. Then downwards, it would cover a distance of 20 meters. It's okay to call it negative 20 from the word go. So for case 1, V is equal to U minus GT. At maximum height, V is 0. Therefore, T would be U over G, which will give us the initial velocity is 14 divided by 9.81. What time do you get?
1.4271.
1.4271. So one can calculate and say it's 1.43 seconds or 1.4 seconds. Then Roman 2, the time it takes to come back to the same level of projection. Remember, he said at the same level, displacement is 0, and from S is equal to UT minus GT squared all is over 2. This should be 0. And we saw that time when factorized will give us minus GT over 2 is 0. Therefore, this time is equal to U minus 2U out of G. Ideal time of flight, which is 2 times 14 divided by 9.8, which is giving us 28 out of 9.81. What time is this?
$2.854.
Then the last one says, find the time it takes to hit the ground. So the time it takes to hit the ground, still the particle is projected upwards with initial speed u minus gt squared over 2. Because the particle has gone up and coming back below the level of projection, we say that vertical displacement is a negative. So we shall have negative 20 is equal to 14t minus 9.81 t squared over 2. Negative 20 is equal to 14t minus 4.905 t squared. So 4.905 t squared minus 14t minus 20 is equal to 0. So when you press the quadratic, what do you get?
$3.8997. Negative 1.0456.
So the answer is time is 3.9 and 1.04 negative, but the negative is not correct because this is a real aspect, which is seen. It is not an ideal project or an ideal ideal situation. Then the other way we can also do it is by finding time of maximum height, which we got, then time from maximum height to down where it strikes the ground. Can find this as time t2. From v is equal to u minus plus gt because it's coming down. The final velocity, we know the final velocity. The final velocity, we don't know it, but we can find it. From v squared is equal to u squared plus 2gh minus 2gh. So the final velocity can be got from 0, from 14 squared, minus 2 times 9.81 times the height, which is negative 20. This will give us 196 plus 4 times 98.1. What answer do you get for v squared? Actually, find the square root at once.
$24.26.
24.26 meters per second. Now, when you substitute here, because it is coming from up here, this is the initial velocity. So the final velocity down here is v prime, which is 24.26. So you will have 24.26 is equal to 0 plus 9.81 times time. So this time is going to be t prime is 24.26 divided by 9.81. What answer do you get?
$2.48. No, 2.47. 2.47.
2.47 seconds. So the total time would become what is the first time of flight? We go to our maximum height 1.43 plus 2.47. We get exactly 3.9. Hashtag very correct. Yeah. Hope that's the answer, right?
Yes, teacher.
Teacher.
Okay, so the ball is ahead of you for you to chase and solve as many numbers as possible for both linear motion and vertical motion. In A-level, I told you we do not follow you up a lot on marking whether you've done the work. It is more of maturity. So I expect you to do the work and send me challenges. By the time I give a test, you should be able to handle. Otherwise, if no further questions, that topic is over. So I'm going to send more write-up on notes, and then you'll have them down, mixed with some numbers to try out.
Teacher, which textbooks did you tell we get the work from?
Understanding Mechanics and Roger Moncaster. Did I send you Roger Moncaster? Are you in the group? Send me a message for the
I've
group.
just joined the group.
You just joined the group today?
Yes.
Okay. Okay, then have a good afternoon.